Hello everyone. So friends, in our previous lecture we saw the demonstration of the insertion sort algorithm step by step. So in this lecture we'll code the algorithm and we'll test its working. So here I have created one class as insertion sort. This class has method as print array, which simply prints the contents of this array on the console, which we already discussed in our previous lecture. So here let's say we want to sort this array having 5 elements as 5, 1, 2, 9 and 10. So when we'll print these elements on the console, let's say if I run the code, so here you can see it printed 5, 1, 2, 9 and 10. So here the array you can see is not in sorted form. So let's write the code to sort this array using the insertion sort. So here I will be creating one method as public void. Let's say I give the name of the method as sort. So this method will take the array which we want to sort. In the first step what we do is we simply compute the number of elements inside the array by storing the length of the array to the integer variable n. And then as we discussed in our previous lecture that we start our algorithm with a for loop where value of I will be starting from 1 and not from 0 because the first element inside this array when we pick to sort we know that it's already sorted. So we simply start from the second element. So I starts from 1 and it goes till I is less than n. So friends, we also discussed that when we perform insertion sort, we usually divide the array into two parts. One is the sorted part and the other is unsorted part. So here the value which is tracked by I is usually the unsorted part and the value which j tracks, which we'll see later, is usually the sorted part. So here by providing this for loop, with each iteration we simply pick one element and we place that element into its correct position by applying the insertion sort. So we simply store the first element of the unsorted part into the temporary variable. And after we store this, now we simply access the sorted part. So here you can see that as I is starting from 1, so the element which is stored at the 0th index is already sorted and we can access it via j. So now j will basically keep the track of the sorted part. We provide a while loop where we provide two conditions that j should be greater than or equal to 0. And as we want to compare the value stored into the temporary variable with each and every element stored in the sorted part, we provide another condition as the element stored at the jth index is greater than temp or not. So if this is true, inside this while loop what we do is we simply shift all the larger elements which are greater than temp by one position. And how do we do it? We simply take the value stored at jth index and we transfer it to the j plus 1th index. So here we are simply shifting larger elements to temp by one position, and after shifting the elements we simply decrement the value of j by 1, because inside this while loop we need to compare the temporary variable with each and every value of the sorted part. So friend, why we are shifting all the larger elements by one position, which are actually larger than value stored into this temporary variable, is because we need to find the correct position of the value stored into this temporary variable. So after we perform the shift by one position, we decrement the value of j by 1, and then we again compare it with the value stored into the temporary variable, and this loop goes on till j is greater than or equal to 0. So this is basically a boundary check that we don't go to the out of the boundaries of the array. And after this while loop we simply store the value stored into this temporary variable into its correct position, which is at j plus 1th index, because here we'll exit the while loop with these two conditions, and as we have already decremented j by 1, we know that the correct position for the value stored into this temporary variable would be at j plus 1th index. So friend, after this for loop completes for one iteration, our sorted part increases by one value, and with each iteration the sorted part increases and the unsorted part decreases, and finally when this for loop exits, all the elements of the unsorted part now becomes part of the sorted part. So friend, this is the insertion sort algorithm. We discussed this algorithm in greater detail in our previous lecture, and in this lecture we have simply coded this algorithm. So now we'll test its working. So here we'll call the sort method, we pass in the array, and after the sort happens we'll simply print the array again. So this print array will be called before sort, and this print array will be called after sort. So if I run the main method now, so here you can see the array is already sorted. Initially it printed 5, 1, 2, 9, 10, which was the unsorted array, and then it printed 1, 2, 5, 9, 10, which is the sorting of the array in ascending order. So friend, in this lecture we saw the code for the insertion sort, and we tested its working in main method. I hope you like this video. Thanks, have a nice day.